Hi everyone. In this video we're going to be working on 2012 AP Calculus BC Free Response question number 2. This is a question that deals with vectors, so go ahead and grab your graphing calculators so that we can use it throughout the video. Okay, so let's go ahead and get started. It says for time greater or equal to 0, a particle is moving along a curve so that its position at time t is x of t and y of t. Now remember, anytime they give you a particle in position, whether everything with respect to t, they give you x coordinate, y coordinate, this is going to be the position of the x and the position of the y at any time. So then it tells you at time t equals 2, the particle is at position 1, 5. That means at 2, x's position is at 1 and y's position is at 5. It is known that dx over dt is equal to that equation and dy over dt is equal to that equation. So let's go ahead and get started. It says, it's a horizontal movement. Okay, horizontal movement, what does that mean? Every time you approach these questions, think about what you're reading. Horizontal movement means left to right. Left to right also means the x-axis. So is the horizontal movement of the particle to the left or to the right at time t equals 2? So because this is the horizontal, we're going to look at the x. So what we're going to do is, well, in order to determine if a particle is moving to left or right, we always need to find the first derivative. Luckily, they already gave it to us. So all we have to do for part A is plug in dx over dt, but at times t equals 2. So when I go ahead and plug that in, I'm going to get 2 plus 2 over e of t, or e of 2, which is 2 plus 2 is 4, square root of 4 is 2, so that's going to be 2 over e squared. Now, if you wanted to, you can plug into the calculator to determine if it's positive or negative, but e to the second power is going to be a positive number. Therefore, this value is greater than 0. And you have to remember, every time a velocity at some time is greater than 0, this means the particle is moving to the right. And then when it tells you to explain your answer, just say because 2 over e squared is greater than 0. Okay? So anytime a particle is moving to the right, you have to remember your velocity at some point is going to be greater than 0. If it's to the left, it means that your velocity should be less than 0. So technically negative numbers. Okay? Alright, so let's move on to part B. And then it says, part B says, find the x-coordinate of the particle's position at time t equals 4. Okay, once again, find the x-coordinate of the particle's position. They're asking for position. What position? Of the x. So then you have to remember position's equation. Position's equation is, well, if I want to figure out where the x-coordinate is, it's going to be, well, where did I start from? Well, I know that at time t equals 2, my position is at 1 for x. So that's my starting point. At x 2, plus from 2, because I want to figure out all the area that I'm traveling on the x. Well, I know that I'm at 2. At 2, I'm at 1. Well, how much area am I traveling from 2 all the way to what they're asking me, which is 4? Okay? So anytime they give you a question that deals with position, always remember, you have to add your initial plus the area that you're traveling from your initial value. Okay? So, I'm going to put t plus 2 over e to t. And the next thing is, since we're able to use our graphing calculator, go ahead and plug it in. So, when you plug it into your calculator, what you're going to do is this. Press the math button, scroll all the way down, or press number 9. What you're looking for is an integral. And then you're going to type in your function from 2, because that's my initial, to where I'm trying to find 4 of, and then since we need to create a fraction, so what I want you to do. If you press alpha, then y equals 2, it's going to put n over d. That's what we're looking for. Numerator, denominator, press enter, it's going to set up a fraction. Then type in exactly how you see. Square root of x plus 2, because the calculator doesn't really know if it doesn't really care if it's t or x or any other variable, over e to the x. The last thing you're going to put is everything is with respect to x, so make sure you put dx. Press enter, and this is the area that was traveled. Once again, this is the area that was traveled on the x-axis from 2 to 4. But remember, we have to actually find the position, so we have to add the initial, which remember, x of 2 was what value? 1. 1 plus 0.25295, etc. Add 1 to it, and that's going to give me a value of 1. Remember, in AP Calculus, you need to round to at least 3 decimal places, 1.253. And that is my position for the x-coordinate at time t equals 4. So once again, whenever they ask you position, take account for the initial plus the initial to the value that you're trying to get to. Okay, so let's move on to C. It says, find the speed of the particle. Keyword speed. How do I find speed when it deals with vectors, coordinates? Well, any single time it's speed, this is what you want to remember. Speed is x prime at 4 squared plus y prime of that value 4 squared. And that's going to help you determine speed. So what you're going to do is just go ahead and grab your calculator once again and type everything how you see it. X prime is, once again, you got to create the fraction, but also note that you're plugging in 4. So it's going to be parentheses square root of, actually let's type the fraction in, alpha y 1. Let's start over. Okay. So square root of 4 plus 2, which is 6, over e to the 4, because I'm plugging in 4. Close it, and don't forget to square it. Plus, do the same thing now for the y. Now y is just sine squared t. So this is what you have to be careful about, because when you calculate it, what you're going to actually end up doing is sine squared, sine of 4 squared, followed by a squared. So that's going to be sine 4 squared, technically, close the parentheses, and also square it again, and then press enter, and that's going to give you a value of 0.575. And that right there is the speed of the particle. So once again, when you're trying to find speed, all you have to do is find the square root of x prime plus y prime squared, but you have to plug in the value that they're looking for. In this case, it was 4, so that's why I plugged in 4. And a big part of this question is being able to know how to use your calculator, so you have to be careful, okay? Alright, and then the last part of the question, oh actually I'm lying. For part C, it tells you find the acceleration vector, okay, of the particle at time t equals 4. Well, acceleration, anytime it's acceleration, I just have to find the derivative. So what I'm trying to do is I'm trying to find the derivative of the x at 4 as well as the y, because these are going to be two different positions. So some of us will try to find the derivative by hand of dx to get to acceleration, but remember, you don't actually have to because your calculator is right in front of you. What we could just do is, if you go to math, scroll all the way down to number 8, it says derivative. So it's going to say derivative of what variable, just make it x, and then we're going to type in exactly what we see for dx. So once again, go to alpha y equals 2, set up the fraction, type in the radical x plus 2 over e to the x, and then the last part, the most important part, is over here, x equals to an empty box. Well, at what point do you want to find the derivative? Well, the point that we want to find the derivative is at 4. So we're going to plug in 4, and you're going to get a value of negative 0.41. Remember, around 3 decimal places, this is going to be the acceleration vector at that value, so it's going to be negative 0.41, comma, well, we're also looking for the y. So we're going to do the same exact thing. Go to math, number 8, and you're going to now type in the y function. But don't forget, keep it as x sine x squared. At what value are we looking for? At x equal to 4. And you're going to get a value of 0.989 if you round 3 decimal places. And that is part, technically, B of C, okay? So finding acceleration. So once again, if they were just asking for the acceleration vector, you would just find the derivative of x, dx, dt, derivative of dy, dt, and put it there. But because they're looking at a particular time, you have to find the derivative, plug in 4, find the derivative of y, plug in 4, and just leave it like that because this is in vector form. Okay? Alright, now moving on to D. D, once again, keywords. Find the distance traveled. Okay, keyword, distance traveled. Well, distance traveled means how much did I travel from where to where? Well, it's asking how much is the distance traveled from the particle from time t equals 4 to 2 to 4. Okay, well, I already know at time t equals 2, I'm at 1,5. But this is the one thing that you have to remember. They're only asking me for the distance traveled between 2 to 4, so I don't really care about my initial. I only care about how much I travel from 2 to 4. Well, distance traveled is like this when it comes to vector. you're going to set up an integral from point A to point B, in this case 2 to 4. You're going to put a square root, and you're going to put dx over dt squared plus dy over dt squared. This looks identical to the speed, except you're not trying to find an integral because we're not trying to find area for c. C, we're trying to find speed, so that's why we plugged it in. For distance, we're always going to set up an integral from point A to point B of the same exact equation. Okay, so then once again, set up your integral. So math to 9, and what you're going to do is you're going to go 2 to 4, and then you have to be careful again, because remember, we're going to put everything in. So square root, parentheses, alpha, set up the fraction, type in the dx over dt, close it, don't forget to square it. So you should have that, looks good as of now, plus same thing with y's. So it's going to be sec sine x, close the parentheses, square it, but also don't forget to square that as well. Why? Because this is sine squared, but we're about to square it. So technically you could put sine to the fourth if you wanted to. Then I'm going to close it. That's my integral. Then it's going to ask you which letter are we integrating from. Everything we did was x, so you're going to put dx at the end, integrate it, and we're going to get a value after the calculator stops working of 0.651 if we round 3 decimal places. And that is going to be the distance traveled by particle position from time t equals 2 to t equals 4. Okay? So once again, this is not a tough question. The only thing is that you have to know how to work with the speed equation and the distance traveled equation. Speed and distance is almost the same thing, except speed you're plugging a value in, and for distance you're setting up an integral from point A to point B. Okay? So I want to thank you guys for watching. Let me know how it went, and good luck.